Welcome back, everyone. Dr. Tom McNamara here again for our course in college algebra. In this video, we are going to talk about ways to make sense of negative number exponents and fraction exponents, because we're going to get into exponential functions. So we're going to need to deal with inputs that are negatives and fractions. So let's just get started with an example here. I'm going to write down a sequence of numbers. There is a pattern to these. Let me give myself a little more space. I'm just going to write down the same sequence with... Okay, so I've got my four numbers there, and you can probably determine the pattern pretty quickly. I am multiplying by 2 to get the next number in the sequence. So if you start here, multiply by 2, you get 4. Multiply that by 2, you get 8. Multiply that by 2, you get 16. Multiply that by 2, you get 32. 64. You can keep on going as long as you like. So to move to the right, I would multiply by 2. Now, I'm actually more concerned about moving the other way. If I want to move to the left, what would I do? Well, I would do the opposite of multiplying by 2. In other words, I would divide by 2. Okay, because if I'm here and I want to go left, so I take 16 and cut it in half, I get 8. If I cut that in half, I get 4. If I cut that in half, I get 2. And if I cut that in half, I get 1. I can keep on going to the left if I like. If I cut 1 in half, I get a half. You cut a half in half, and you get a quarter. Right? Half of a half, that's a quarter. 1/8. 1/16. Okay? So, pretty simple idea. You want to move to the right, you multiply by 2 in this sequence. If you want to move to the left, you do the opposite of multiplying. You divide. Now, I want to look at these numbers in a different way. These numbers are all powers of 2. 2 to the first, of course, is just 2. 2 squared means 2 times 2, which gives me 4. 2 power 3 would mean 3 factors of 2. 2 times 2 times 2, which gives me 8. This would mean 4 factors, 2 times 2 times 2 times 2, to get to 16. Okay, so this is just another way to express the terms in the sequence. And we can see a new pattern. You want to go to the right, you add 1 to the exponent. You want to go to the left, we should do the opposite. So we should subtract. Subtract 1 from the exponent. Because if you're here and you want to go left, well, you don't add 1 because that'll take you over here. If you lower the exponent, now you get here, 2 to the third. Lower the exponent by 1 again, 2 squared, 2 to the first. So the thing that would make sense here is 2 to the 0. 2 to the negative 1. We're just going to continue the pattern. 2 to the negative 2. 2 to the negative 3. 2 to the negative 4. Okay, so there is a way to make sense of negative exponents. Okay? So the general rule here is that if you take something to a negative power, you are going to get a fraction. Okay? So a to the negative n is 1 over a to the n. Because look here, right? 2 to the negative 2 is the reciprocal of 2 to the 2. 2 to the negative 3 corresponds to 1/8. That's the reciprocal of 2 to the 3. Okay, so there's a way to make sense of negative number exponents, and that is reciprocals. Negative exponents give you reciprocals. Okay, And also, there's, I guess, a second rule here. 0 exponent gives you 1. Okay, anything to the 0 power gives you 1. See right there? Okay. So let's do a similar sequence. Okay, so okay, now you might say, all right, well, that's the exact same sequence. It's not similar, it's the exact same thing. Okay, not quite. Notice I left these gaps here because I'm not multiplying by 2 to get from one term to the next in this sequence. What I'm doing is I'm actually multiplying by radical 2. Okay, so if I'm looking at this, if I take radical 2 and multiply it by another radical 2, I get 2. That's what this number does. The square root of 2 is a number such that when you square it, you get 2. Okay, that's the function this number fulfills. Okay, so now, if I have 2 radical 2, and I multiply by another factor of radical 2, the thing is whenever I get 2 of these together, whenever I get 2 of those multiplied together, they multiply together to give me a 2, so that gives me 4, okay? So if I hit this with a radical 2, I get 4, okay? So that's what I was doing in the background there. Okay. Now, we know from what we just discussed that these terms, 1, 2, 4, 8, 16, we know that those are all powers of 2. Okay? So the question is, what power should this be? Can we make sense of it as a power? And the answer is, yes, we can make sense of it as a power. What we need is a power that's between 0 and 1. And 1/2 power is the one that does the job. Okay, this is a power that should be between 1 and 2. 1½ or, as a fraction, 3/2. 2 to the 5/2, 2 to the 7/2, and so on down the line. Okay. So there is also a way to make sense of negative exponents, and that is in terms of roots. Okay, roots. So the general rule is a to the m over n is equal to the nth root, so the denominator tells you which root to take. If the denominator is a 2, we're going to do square root. If the denominator is a 3, it would be cube root, and so on. And the numerator tells you the power. And you can do this in either order. I typically do the root first and then the power. So this is the preferred method for dealing with that. Okay, so we've got a couple of new rules for exponents, or a couple of new exponents that we can deal with. We have 0 exponent, we know how to deal with that. Anything to the 0 power is 1. We know how to deal with negative exponents. Anything to a negative power, that's going to be the reciprocal of the corresponding positive power. And now we have a way to make sense of fractional exponents. So let's work a couple of examples where we do computations with these negative and fraction exponents. So I'm going to evaluate each of these. Okay, let's start with an easy one. 3 to the negative 2. Okay, So we just discussed how to deal with negative exponents. 3 to the negative 2 should be the reciprocal of 3 power 2. And that is 1/9. We know what 3 to the 2 is. It's 1/9. Easy. Okay, let's do a fraction exponent. 64 power 1/3. Okay. So if you look at what I just did, I guess we're doing that. Okay, first power doesn't really change anything. We really need to focus on this. Okay, cube root of 64. Okay, now a square root is a number such that when you square it, you get your target, like this here. Square root of 49 is 7 because 7 squared equals 49. Okay, if we're talking about a cube root of 64 equals, well, let me put a blank there. What I'm looking for is a number that I can raise to the third power and get 64. Okay, so I have to fill in this blank here. I'm trying to find a number such that when I raise it to the third power, I get 64. Okay, well, let's just kind of go down the list. Take 1, raise it to the third power, you get 1. Okay, that's not going to help. Take 2, raise it to the third power. 2 times 2 is 4, times 2 again is 8. Okay, that's not it. Take 3 to the third power. 3 times 3 is 9, times 3 again is 27. Not quite. How about 4? 4 times 4 is 16, times 4 again is 64. So 4 power 3 gives me 64. That means the cube root of 64 is 4. And 64 to the 1/3 is another way to talk about that. Okay, it's a way to talk about it with powers. Let's do something like this. Let's do 27 power 2/3. Okay, so cube root of 27 and then square. I typically do the root first because you'll get a smaller number and then you can raise it to a power. All right, now we just talked about the answer to this. Okay, you might not have noticed it in there, but I was going through the various cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So the cube root of 27 is 3. So we do the root and get 3, and then we're supposed to square that, so we get 9. Okay, so 27 to the 2/3 power is 9. Okay, so in the exercise set, you'll have some practice problems that have you work with fractional exponents and negative exponents. Okay, very easy to make sense of these concepts, and they extend our understanding from what we already know with positive whole number exponents. Okay, so make sure you work through those practice problems and get comfortable dealing with these negative exponents, fractional exponents, and 0 as an exponent.